Carl Fredrich Gauss. A discovery can lead to your legacy. The story of Carl Fredrich Gauss shows this. Gauss was born a genius, prospering from poverty to becoming a prolific mathematician. Gauss was a famous mathematician who devoted his life to studying different subjects to make a difference. Gauss discovered new mathematical equations and techniques like the Gaussian elimination, which we use in this class. Early life as a child prodigy. The child prodigy was born on April 30th, 1777 in Brunswick, Germany. According to Sherry Chasen Calvo, Gauss was born into poverty with an illiterate but smart mother and a poor bricklaying father. His financial class did not stop him from success because as a young child, his intellectual capabilities kept flourishing. At a young age, Gauss was capable of correcting a mistake from his father's wage calculation. At approximately 9 years old, Gauss was in the class when his teacher wrote a problem on the board. The problem consisted of adding integers from 1 to 100. Gauss quickly was able to find a solution faster than anyone in his class. It is assumed, according to science at his time, Carl was able to find the sum of 1 to 100 in the sequence when the greatest number in the series, being 100, is added to the least number, being 1. The result is 101. When the second highest number, 99, is added to the second lowest number, 2, the result is 101. When the third highest number, 98, is added to the third lowest number, 3, the result is 101, and so on. Because there are 50 pairs of integers between 1 and 100, the sum of these integers is 101 times 50, or 5050. The quickness and intelligence amazed his teacher, who notified a duke. The teacher notified Duke Brunswick, who was amazed at Gauss's geniusness. The duke chose to financially sponsor Carl in advanced studies. This is a sequence that people have said that Carl used to find the sum of 1 to 100. The historical time frame Carl Friedrich Gauss lived during was the modern era in the 19th century. During the 19th century in Germany, the biggest occurrence was a revolution. The German Revolution included tremendous changes to the tradition and more political conflict. The German Revolution impacted mathematicians since mathematics became more important to acquire far more rigorous concentration on legitimate discoveries. According to a biography published by Charles Schreiber's Sons in Carl Friedrich's lifetime, he experienced political turmoil and financial insecurities associated with the French Revolution and the democratic revolutions in Germany. The work discoveries of mathematician Carl Friedrich Gauss relates to our course because we can use the Gaussian elimination. In this class, we solved linear equations and also a system of linear equations. There are many ways to solve a system of equations. The three main ways to solve a system of equations are substitution, graphing, and elimination. The Gaussian elimination can be used to solve a system of linear equations. According to the book from our class titled College Algebra by J. Abrason, in section 7.6, Solving Systems with Gaussian Elimination, the Gaussian elimination method refers to a strategy used to obtain the row echelon from the matrix. The goal is to write matrix A with the number 1 at the entry down the main diagonal and have all zeros. Here is an example of how to use the Gaussian elimination to solve a system of equations. Here We used the elimination to solve a 2x2 system of equations. The first thing we have to do is write the system as an augmented matrix. We would do this by having the coefficients in this matrix. So we would have, because there's a 2 and it's a coefficient, we would write 2 here. And there's a 1 here, coefficient. We put it down here, and then there we would have a diagonal bar, not diagonal bar, a vertical bar, and then we would put at the end. So we put 1, and then we would do the same to the other system, to the other equation. So we would have this one down here. To obtain a 1 in row 1, column 1, this can be accomplished by multiplying the first row by 1/2. So we were trying to get zeros to find the value of x and y. So we would do 1/2 times the first row. So we would do 1 times 1/2 times 1/2. So we would do 1 times 1/2. And we would always do it to the first row. Now we want a 0 in row 2, column 1. Multiply row 1 by -4 to get a 0, and add 1, and add row 1 to row 2. So here it would just give us what equation we're going to be doing. So here we're going to be multiplying -4 by row 1. So we're going to be doing it to the first row here. And then we're going to be adding row 2. So the second row represents the equation 0 equals 4. Therefore, the system is inconsistent and has no solutions. This is how we would use the Gaussian elimination to solve a system of equations. Carl Fredrich Gauss is the most influential mathematician of the 19th century. His life story is practically fascinating because he came from nothing but was able to uncover discoveries in mathematics. Throughout his lifetime, Gauss had many struggles because of the historical climate he was living in, but he still focused on challenging himself for discoveries. Carl had many influential contributions to the discovery and advancement of mathematics. Gauss had many techniques and discoveries named after him. A relevant method we talked about is the Gaussian elimination, which helped solve a system of linear equations. Thank you for listening to my presentation of the life of Gauss, Carl Friedrich Gauss. These are my sources. Thank you.